is called a table drawing. So here's kind of an example. We've talked about this the other day. It's been a little while, but here's just a basic spacer that has, you know, a washer type shape that has an outside diameter, inside diameter, and a thickness. So this one drawing is used to make all three of these different parts with these different sizes. So we use, instead of dimensions with hard numbers, we use dimensions with a variable and then a table that tells us what that variable value is for each individual part. So this is very common in industry. When you have similar parts, it's not worth the energy to create an individual drawing sheet for every single spacer. We just add the spacer that we need to the table with the sizes that are appropriate for it. Does that make sense? So this is your goal of what you're looking for, is create the drawing views that you need, replace the numbers in the dimensions with a variable, and build a table. Excuse me. Your table, I want to point out, each row in the table should be an individual part, and the columns will be your dims. Okay. And you'll start at A and just go, you know, progress without skipping anything. Now, some organizations do elect to skip the letters I, let's see, and O, just because they could be confused with ones and zeros. Some organizations don't. You may or may not, but that's not uncommon to see that practice. But we're not going to go that deep into the tables that we're going to make. So this is a sample of what I'm expecting you to do. But here's the actual part that I want you to do it with. It's this bracket. So this bracket, there's 4 different brackets. They're all the same basic size, and they all have the same features, except for this one bracket has a hole in the bottom of it. Okay. So when you elect to choose which one you're going to show, you always need to show the one that has, you know, all the features. So you couldn't really show one of these that doesn't have a hole and be able to represent that hole on this one in the table very well, right? But what you'll do in the table, you know, if you've got this called out as, say, diameter D, right? So in the ones where in the table that don't have a hole, it just has a dash there, you know, and the other one has a diameter, you know, 1. This one doesn't have a hole, it just has a dash in that column on the table. Does that make sense? So just dash where there's no holes. And it's also a good practice to say part number such and such shown on the drawing so that you know which one you're actually looking at on the drawing. So you're going to create the shape. Whether you do this in Inventor or AutoCAD, it doesn't matter to me. I'm not looking for isometric. Yeah, I am looking for a pictorial view, so it'd probably be smarter to do it in Inventor because that you get that view for free, right? And in AutoCAD, you got to work for it a little bit. But I don't want the numbers in the dimensions. I want those to be variables. And I want you to do A, B, C, D, so on. If it's a diameter, put the diameter symbol in, oh, where my other one went, I guess I closed it. Put the diameter symbol in the dimension here. So diameter B, and then we just go to B to see what the number is. Piece of cake?